I'm Aaron Evans. I'm going to talk about QA strategy, how I implement it, and what we can do. The first things I want to talk about are what are our limitations and constraints? What are your goals for QA? What do you currently do with testing? And what are your known limitations or challenges? We need to talk about things like time and budget, uh, what people you have, and what their skill or specialty is. And then things like processes, tools, and technologies that you use that you want to be adapted in your QA strategy. So it starts off with the product. We talk about your product. What does your product do? What value does it provide to you as an organization? And what do your customers value from your product? That will influence how we want to test and what we want to prioritize. We need to look at the features in your product, the requirements of those features, what components or different pieces or points of integration your product has, and understand where to test. Now, personally, I've seen integrations are an area that typically need more testing and have more bugs. These are the points where two different parts of the system or two different systems work together. And often a lot of exploratory testing is needed at those integration points. And a lot of things can't be anticipated before going live. Things that you will find in production that might come from an external service that you would never anticipate in initial testing. These are things to think about as you think about how you're going to test your product. All right. I like to stress an iterative process. QA isn't something you check off and say it's done. It should be something you do at the start, not at the end. You should be thinking about quality. You should be thinking about how you're going to test, how you're going to structure your system to test. And it's really important to realize that it's not something you can just do and it'll be done. Tests are code, or test automation is code. Tests are documentation, and both documentation and code tend to be subject to entropy. There's a thing called code rot. Production code needs constantly maintained. Test automation code needs constantly maintained, especially as you discover and add new features and requirements. Well, this might change your user interface. This might change the way your backend interacts, or change the way data is presented or analyzed in your application. That affects the tests and causes them to break or need to be adapted. All right, getting down to testing. There are a lot of things to be done with testing. And first thing I want to talk about is different types of tests, right? There's functional tests or regression tests. These test what your product does. Does it do what's expected? Does it not do what it shouldn't do? Exploratory tests. This is the creative test that is usually best done with a person behind the keyboard, not automation. Exploratory testing is the testing that finds bugs. How can you break it? Destructive testing. This is something that is usually not automated, but something that automation usually can't replace. Now, performance and load testing. How fast does your product work? How fast does a page load, or how long does it take for something to interact? That's a performance test. Load testing is another aspect. How can your system perform under load if you have 100 users versus 1,000 versus 1,000,000? These are things to consider, but are things that are often left till later. The environment that you work on, your test environment, often can't give you accurate performance and load metrics because it's not the real world. It's not the same systems. It's maybe an underpowered computer, and it doesn't have a real load of hundreds or thousands of users. So we try to anticipate that, and performance is often done at the end because of that. But security is not something that should be left at the end. We want to talk about how can your system break? What happens when malicious actors, hackers, or whatever are trying to break into your system or bring it down? And then how can we safeguard against that? And how can we provide safety checks through things like static code analysis, known issues? OWASP has a list of known security vulnerabilities that you can check against as well. Talk about manual versus automation. Manual testing, as I said, is usually the best way to do exploratory testing. You have a mind behind the keyboard or the mouse or the finger swiping on a mobile app that is trying to explore or break things. A person can also notice many things versus automation. Automation can only check what you tell it to. Automation is good at covering repetitive tasks, things that are difficult to do manually that require precision, or things that are known what to do and what not to change. So going back to the other, functional test is good for automation. Automation can also be used to simulate a load, and it can help with things like security testing as well and load testing. Let's talk about priorities. You can't test everything, but you need to know how to test those priorities. You've got a bunch of features, a bunch of requirements, a bunch of different things that need tested. How do you decide what to test first? Well, you prioritize them. And the way I like to think about those risks are what is likely to break, what is complex, what is so to think about what is the impact if something goes wrong. For instance, if you leak all your customer data, that could have a high impact on your business versus if people just see a pop-up and they just have to dismiss it. Low impact versus low likelihood or high likelihood. Those are things that you want to evaluate. There's a risk-based matrix I use to evaluate what are the high priority based on that impact and likelihood. All right. So we've talked about testing, but we haven't talked too much about automation. Automation has several parts to it, right? You have your automation framework. How are your tests executed? And you might have different libraries. Things for automation like Selenium or Cypress or Playwright, or different tools for validating your backend, your APIs, your database, or whatever. And then there are certain patterns that make tests maintainable and easy to debug to find out where things go. You need to follow single responsibility principle. Keep it simple, and separation of concerns are good patterns for any code, test automation or otherwise. And then we need to know what data it is. Data is an important part of our tests, the different data that you need to use and exercise or expect. So what automation does? Automation does something repeatably over and over again. That's what it's good at. What it's not good at, as I mentioned already, is doing different things, noticing things that are not anticipated, doing exploratory. Although you can use some tools, they call them fuzz testing or monkey testing, which automation can supply. But automation is good at those repeatable, known, expected things, verification of what's working, not at finding bugs, not at, believe it or not, saving time or money. Automation is a force multiplier, and I'll talk more about that, not a way to make things faster. The purpose of automating is to create a feedback loop, and that feedback loop allows you to adapt to change. It allows you to make changes as you learn more about your product as it develops, and as your time and budget may change and other foreseen things. Continuous delivery. This is the next phase. We have tests that are automated. We want to have that automation move into that feedback loop, and that's what continuous delivery does. It allows our tests to execute on demand whenever we want. It allows them to execute on a schedule. Say every day you can have a test run and get that feedback loop, or you can have it execute every time there is a code commit or a deployment. Continuous delivery is that key to getting that continuous feedback loop from our testing. For continuous delivery, there are several parts. You need to have a service, something like Jenkins or GitHub Actions, to run that continuous delivery. You need a place to execute that test. That's the runners or agents, as it's called on some system. You need to be able to test against certain platforms, different browsers, different operating systems, or mobile devices. And lastly, you need things that you need to be able to execute. That's your tests. All right. After we're running our tests, our automation and continuous delivery, We need that fast feedback to be meaningful results. We need detailed test reports with logs, stack traces, screenshots, steps, and all that for those executing the tests and maintaining them to be able to know what happened, why, and how to fix it or troubleshoot the issue. But we also need high-level results, what passed, what failed, and what requirements are covered. So having those meaningful results, having those reported in a way that's valuable to the different parties is important, whether it's the testers who are writing the tests, the developers who will be fixing the issues, the product owners who care about the velocity, or the operations team that wants to know if a deployment went successfully. All right, reporting. This is what I led into. Those different types of reports that are meaningful to the testers, the developers, operations, or whoever. We need a reporting mechanism that happens after the tests run. It can gather those results and present them in a summary or a detailed way. We need to be able to send notifications to say that the test run completed, here's the results, and here's a way to dive into that more detailed test report based on your needs. Simple pass-fail rate. We have 100 tests, 90 of them passed, 10 failed. Let's find out why. And then those artifacts I mentioned, like screenshots and logs. All right. I want to stress lastly that testing and test automation is not a way to speed things up or to save money. If you're looking for that, someone else might say they can do that, but I don't believe that. I believe testing is a force multiplier, and automation is a force multiplier of testing. I stressed the importance of exploratory testing to find bugs and find ways to improve your product. Test automation takes the burden off of testers from doing that regression testing or that functional test validation to be able to allow someone who's doing that to do the exploratory testing, to be the creative person analyzing the results. It's also a force multiplier for developers. That fast feedback loop lets developers know in minutes instead of hours, days, or months when a bug is introduced. The quicker a bug is introduced, the easier it is to fix. And then it can also be a force multiplier. It can let the manager or the product owner know what the velocity is so that they can make decisions and plan for the future, whether they want to add or remove new features or change their deadlines. And lastly, for operations, it's a multiplier because it lets them know quickly and confidently when new code is deployed. Is it working? Can it be trusted? Or does it need to be rolled back? That's all for me. I'm Aaron. My company is OneShore, and we provide test consulting and solutions, and I'd love to talk to you more about it.